Okay. Hello everyone, welcome to Code Enzyme, and in this video we will discuss this problem multiplicative arrays from Codeforces around 998 Dev 3. Okay, so let's first before even starting I will tell you that this problem will have some prerequisites. You should know basic knowledge of how to get an array of factors of a number. So you should have some knowledge of number theory and a little bit of dynamic programming. So if you are not comfortable with these topics yet, maybe you should study these topics first, and then you can come back to this problem. Okay. Yeah. Okay, so now let's read this problem statement. You are given an integer k and n. You are given each integers. For each integers x from 1 to k, you need to count the number of integers integer array a such that all of the following are satisfied. So we want to create arrays of length n. It can be less than equals to n, and such that ai is till k and the product is equals to x. Okay, and we want to print the answer modulo this number, this big number. Yeah. So yeah, I did upsolve this problem, and I personally feel that the editorial was not very good. You have to keep reading it and come back to it a couple of times to actually understand this problem. Yeah. Okay. So let's start. Let's first discuss the sample test cases that we have. I think I will just do it till this much. Yeah. Is the pen working? Mm. Okay. So now that we have everything set up, let's discuss the sample test cases first. First we have in this first test case where k equals to 2 and n is also equals to 2. So what do we have? Like for x equals to 1, the answer will obviously be, I can form this array or I can form this array. There are no other possibilities, right? So the answer will simply be 2. So that is why we have a 2 here. And for x equals to 2, what can we do? One possibility is this, other possibility is 1 comma 2 and 2 comma 1, right? So the total number of arrays is simply 3. So that is why we have a 3 here. Okay. Let's see the next test case, that is 4 comma 3. This is the more interesting one. So we have k equals to 4 and n equals to 3. Okay. Simply for x equals to 1, we have 3 kinds of array, I think. Yeah, 1, 1, 1, 1 and 1, 1, 1, 1. So I think we can even generalize it here that if x is equals to 1, the answer will simply be n, right? It can't be more than n. No. For x equals to 2, this will be interesting. We have a 2 here. Then we can have 2 comma 1, and we can have, obviously we can do alternate these, right? So we can do 1 comma 2, and we can do 2 comma 1 comma 1, and the permutations of this that will be 1 comma 2 comma 1 and 1 comma 1 comma 2, right? So the total number of arrays is 3 plus 2 5 plus 1 6. So in here we had 3. Then for this x equals to 2, we have a 6. So 3 6, and similarly you can see like x equals to 3 will be same, just instead of 2 we will put a 3 here, like that. I think I will just directly go to x equals to 4. Okay, so for x equals to 4, we have like one element can be 4, and then there are no possible permutations, right? Or what you can do is you can for length 2, you can do is you can put 1 here, and it can go like 4 1 and 1 4, right? But we also have 2 comma 2. Yeah, and now we can put 1 with this, so like it can become 4 1 1. This will give me 3 permutations, right? 1 4 1 and 1 1 4 and putting 1 here will also give me 3 permutations, like 2 2 1, 2 1 2, and 2 not 2, sorry about that, 1 1 2. Yeah. Is there anything left? Let's just count. So this is, I think, 6 plus 3 9 plus 1 10. So this will give me 10. So that is why we have a 10 here. And similarly we can go on counting, and that will be the answer. Okay, so how do you calculate it naively? Like if you read the editorial, and the purpose of making this video is simply to make you understand the editorials, right? So if you just look at the editorial here, the first line that we have is this one. So first I will try to derive this naive solution, and then we will go into the dynamic programming one. Okay, so how do we calculate the okay, let's say we have not looked at the editorial at all. Okay, so if you are trying to make an array, so let's fix the length of the array first. Let's say I want to have n length array. Okay, or let just for an example, let's keep it like I want to have a 3 length array. Okay, and my x is something like prime p to the power alpha. Let's say p1 to the power alpha 1 into p2 to the power alpha 2 into p3 to the power alpha 3, and so on, right? So if you have something like this, let's say till pn to the power alpha n. Okay, so what we want to do is we want to distribute these alpha 1 into these places, right? Like we can have some equation like x plus, since there are 3 places, we can have 3 variables, x plus y plus z equals to alpha 1, right? And the number of permutations will be simply the number of integral solutions of these equations such that x comma y comma z is greater than equals to 0. And if you are okay, so if you know about combinatorics, this should be easy to solve. But if you are not comfortable with combinatorics, okay, yeah, I will try to prove this for you. Now those who know the proof can skip this video a bit ahead. Okay, so yeah, how can you actually prove it? You can assume like you have alpha 1 balls, so 1 2 3 4. Okay, let's first derive for deriving this. What you can do is, let's put another constraint that x comma y comma z is greater than equals to 1 first. Okay, if they are greater than equals to 1, let's say we have alpha 1 balls, so 1 2 3 4 till alpha 1, right? So I want to put 2 sticks like this in these spaces that were created in between them. So if you see, the number of spaces that were created in between them will be alpha 1 minus 1. How? Let me just show you. Like let's say you have 4 balls. Then you have 1 2 3 spaces created between them, right? So you have alpha 1 minus 1 choices, and in this, from these spaces you want to select the number of variables minus 1. So like I can select like this two spaces, and this will divide the balls into 2 1 and 2. So this is one of the integral solutions that I will have, right? So that will be the number of ways. So it will be like r minus 1. R is the number of variables. Okay, so yeah, for this case this is the solution. Okay, so now for the case when these two for the case when x comma y comma z are greater than equals to 0, so let's say x y z are greater than equals to 0. For this to exist, let's just assume something like, since x y and z are greater than equals to 1, what we will do is let us assume x is something like t1 plus 1, y is equals to t2 plus 1, and z is equals to t3 plus 1, right? So in this case, t1 is greater than equals to 1, t2 is greater than equals to 1, and t3 is also greater than equals to 1, right? Let's put this value in this equation. Actually not plus 1, I think it should be minus 1, right? Sorry about that. So let me just erase this, and this will become minus 1. Yeah, so since t1 t2 t3 are greater than equals to 1, x y and z are greater than equals to 0. Okay, So when you put it, the final equation will become t1 plus t2 plus t3 minus 3 is equals to alpha 1, and you can just transpose this on the right hand side, this minus 3. It will become equals to alpha 1 plus 3, and since these are greater than or equals to 1, the number of solutions when you put it in this formula is equals to alpha 1 plus 3 minus 1 c 3 minus 1, which in general we can say alpha 1 plus r minus 1 c r minus 1. Okay, so yeah, so that was the formula for combinatorics. And yeah, so how can we find the number of solutions for this? For a particular x, what you can do is you can just just use a summation from I equals to 1 to n, and just simply put this formula alpha 1 minus I plus 1 c I minus 1 yeah into if you have more than one prime numbers, then you can do alpha 2 minus I plus 1 c I minus 1, and this you will do till the end, like alpha 3 minus I plus 1 c I minus 1, sorry, alpha n, let's make it alpha n. Okay, so yeah, so this whole thing, this naive approach will cost you like big O of n into the number of x values are k, and this step, like the number of primes will let us assume like it is around log n or log k. So it is something like this kind of solution which will surely give you a TLE, right? And yeah, so that is that. Now if you read the editorial, like it says like this is some function they have defined. Like if you can't understand this, I will just also try to explain this also. They have defined a function fk n is equals to the number of arrays of length n whose product is k, right? Whose product is k. Now how do we reach that formula like they have given? So for that, what I mean, it is pretty obvious. Like if you want an array of length 3, let's say 3, let's say 24. Okay, so the number of factors like 2 into 12, 3 into 3 8s are 24, and 4 6 are 24, and like that you will have various factors of this number, right? I think yeah, it will be only 6 factors, sorry about that. Yeah, but the point is, like if you want the product to be 24 and length 3, so the point is, let's say you have these 6 numbers, and the number of arrays with product 24 and length 3 will be equal to the number of arrays with length 2 and product as 12 plus number of arrays with length 2 and product 8 plus number of arrays with length, because let's say you fix one number 2 here, so the amount that is left in the product is 12, right? So the number of so if I fix one number and the number of arrays with length 2 and product 12 is remaining, so the number of arrays with I fix 3 in the first place, then the number of arrays with length 2 and product 8 plus we fix 4, so like that. Yeah, so basically it from this step we can say like f k n is equals to summation such that I divides p, and obviously I is greater than 1 over all possibilities, and it will become I by p n minus 1. So we fix we fix the first number as I, then we still have n minus 1 places left. We still have n minus 1 places left, and this is represented by f I by p. So this is the amount of product that is left. We need to make this product in this length and n minus 1, like that. So that was how you can use this, and this will also cost you the same. Like you need to first calculate the values of all I by p, so that will give you like log n time, complexity. This will run in k time, and this n minus 1 is big O of n time. So when you multiply this, it will it is the same time complexity, big O of n into k into log, I think log k time. Yeah, so this kind of complexity you will have. This will give you a TLE. So that was the naive approach. So one naive approach is this, and another naive approach is this. Okay, now let's see the constraints first. If you see the constraints, k is going till 10 to the power 5, right? And n is till 9 into 10 to the power 9. Okay, 9 into 10 to the power 8. Okay, and if you see what is 2 to the power 16, let me just undo this. 6 or 536, it is 65536. Let's also see 2 to the power 17, it is 131072. 131072. So this is 1 2 3 4 5, almost 5-digit number. So 6 into 10 to the power 5, right? 1 2 3 4 5, and this is 1 2 3 4 5 6, 10 to the power 6. Yeah, we can see like 17 is just greater than 10 to the power 7. 2 to the power 17 is much more greater than 10 to the power 17, right? And 2 to the power 16 is just greater than 10 to the power 5, the k value that we have here. So what we can see is that majority of the elements in this array will be 1, right? Why? Because let's say you have an array of 2, so you can't go into multiplying like 2 into 2 into 2 into very n times. You will have a maximum of 32 to the power 32 in the factor, because if you go like 2 into 2 into 2 into like more than 32 times, it will obviously exceed k, and you don't really need to compute for that, right? So yeah, and that is one of the intuition. So the number of unique values in the array, the point that they are trying to make is number of unique values will be less than equals to 16, right? Yeah. Okay, so what we can do is we can pre-compute the number of arrays. So what we will do is we will use dp to pre-compute we will use dp to pre-compute what? We will use dp to pre-compute the number of iteration, the number of arrays, such that they have j non-1 elements. So we will try not to use ones, and obviously the maximum length can go till 16 only if we don't use 1. Okay, so let's say dp of ij is equals to the number of arrays that can be formed whose product is I, and length or I can say the number of non-ones element is j, right? So how do we calculate dp of ij? Like what is the progression? Obviously one thing is sure, like let's say the base case is equals to dp of why did I write a b here? Okay, so let's say dp of I and j, I mean I and 1 will obviously be 1, right? Because you have only one element, let's say 6, the number of ways to form one length array using 6 is definitely 1, right? Like 6 and 4, so these will be only one array. Okay, let me erase this now. Now let's say, I mean, we will use the logic very similar to this one. If you saw this, how you can actually, not this one. We will use the logic very similar to this part that we have. So how does this DP progresses? Let's say we have. So first of all, I will set like all of these to 1. So yeah. So similarly, the DP of ij is equals to DP summation for all the prime numbers that divide I, and DP of it will be like I upon P and j minus 1, right? Um, the idea is the same, that let's say you want to find the all the number of arrays for whose product is 24 and length is, let's say, 5. It is equals to, let's say you fix one of the, so since the length is 5, let's say you fix one of the number as 2 in the starting. So this so the number that we are getting is same as the DP of the number of arrays of product 24 upon 2 12 and whose length is 4, right? Plus, now you can set the first number as 3, you still have 4 remaining, so this is equals to the DP of 24 upon 3, that is 8. So DP of 8 and 4. Okay, so like that. So that is why we have a j minus 1 fixed here and I upon P, and we are taking the summation. Obviously P should be greater than 1. Okay, sorry about that. And now I will rub this. Okay, so that is how you can pre-compute this. Now how does pre-computing this part, this DP, is helping me? First of all, let's see what is the time complexity. I can go from okay, I can go from 1, not 1, let's start with 2, because making an array of 1 without using ones doesn't really make sense. So 2 to k, and j will go from 1 to 1 to, it will go to how much? It will go to 16, right? Yeah. Now how does pre-computing this part will help me? For that, let's try to go over some test case. Let's use this one only, 4 and 3. Okay, so in here we had k equals to 4 and n equals to 3, right? So let's forget about this k and let's first try to form the DP array first. When you form the DP array, let's say k equals to 1, 2, 3 and 4, right? And I will start with index 1 only, not 0, because let's have one unique element, right? So obviously for 1 there is only one way. Okay, now in the 2 part, like when you want to have 2 unique elements using 1, so since 2 doesn't really have any factors other than itself, the number of ways to form 2, a product of 2 using 2 unique elements will be 0, right? Actually we don't really need to do for 1, sorry about that. Now this will be like 0, 3, for 3 also it is same, but for 4 we can do summation of sorry, I think I will just write it down for you. So DP of 4 and 2 is equals to DP of, now and it has 2 as its factor, right? So DP of 2 into 1, right? So it is equals to 1. So yeah, I mean basically what I am trying to say here is the number of ways to form 4 is, one is by simply using this, or and other is 2 comma 2. So these are the 2 ways that you can use 4. And actually just for a better test case, what we can do is we can increase the number by something. So let's say n as 4 and let's take k to 6. I think that will be a better example. So let's say 5 and 6. Okay, so we will have ones and ones, obviously this will be 0, and for 6 we will have like let's make it 8 actually, not okay, because 2 to the power 3 is 8, that is why I am trying to consider that example. Okay, So for 6, we will have the factors are 2 and 3, so it will be 2, right? 1 plus 1 is 2, that is why we have a sum as 2. Similarly for 7 and 8, I think it will be, for 7 it is like this, and for 8 the factors are 2 and 4, and yeah, so I think it will be 2 here. Let's try to calculate everything for 3. I think I will just erase this part and remake everything. Yeah. Okay, for n equals to 3, like for 3, what we will have is the number of ways will be or definitely be 0 for 2. This will also be 0. And for 4, the factor is 2, but it was 0. So this will become 0. For 5, it will be 0. For 6, the factors are 2 and 3. So this will also be 0. For 7, 0 definitely. And for 8, the factors are 2 plus 4. So there is one way to represent this like this. Okay. So this is my DP array. Let me just erase this, and so this is my DP array. Okay. Yeah. Now how do we use this? Since there are more values in here, so I will only consider the example for k equals to x equals to 8. Okay. So let's say x equals to 8, and in here I considered like n equals to 4. Okay. Now n can be like very large number. I don't really care about it right now. Let's say n goes till 10 to the power 9, or let's say n is very large. Okay. So we will try to generalize this equation. Okay. Okay. So if you want to generalize it, so if you want to generalize it, let's say, let's first say like, okay, let's first consider the case for one unique element, that is you have 8 like this. Okay. So for length 1 you have this, for length 2 you will have 8 comma 1 and 1 comma 8. Okay. For length 3 you can have 8 comma 1 comma 1, 1 comma 8 comma 1, and 1 comma 1 comma 8, right? Similarly for length 4 you will have like 8 comma 1 comma 1 comma 1, and basically 4 length. I will just write this on 1 8 1 1, 1 1 8 1, and 1 1 1 8, and so on. Okay. And so on. Okay. So like how do we actually calculate it? Like this part, there is only one possibility, there are two possibilities, there are three possibility, and for n equals to 4 we have 4 possibility, and we want to go till n, right? Basically what it is happening is we have one element. Like let's say in terms of balls and boxes, if you consider, you have one box, or I can say like you have one variable in terms of the linear equation analogy. Like in this case we have like x plus y plus z, sorry about that, we have three variables which is equals to 1, and x y and z are greater than equals to 0. That is the analogy. Like we have one ball, we have two spaces, and we can have sticks like this, we can have sticks like this, the analogy of stars and bars, or we can have sticks like this. So there are three possibilities. I mean, like I don't think I'm able to explain you permutation and combination correctly, but yeah, this is how the analogy that made me understand like that. So the answer for this case is simply 1 plus 3 minus 1 c 3 minus 1, right? Yeah. So what is happening is, let me just erase it. So this is like if you try this is represented by like uh, we have two spaces, so 2 c The number of variables are still 2 only. How do I explain this? Wait a second, let me think about this. So this part is represented by like 1 plus the number of variables is 1 minus 1 c 1 minus 1, so that is like 1c0. You can call it like 1c0. So 1c0, and this is like we have two variables and equals to 1, so x plus y equals to 1, so that is like 1 plus 2 minus 1 c 2 minus 1, so that is like 2c1, and this part, the 3 is like 3c2, and this part is like 4c3, right? So the general expression will be like summation from I don't want to write a summation form because that is more tough to visualize then. So I will just write it like this. So the 1c0 plus 2c1 plus 3c2 plus dot 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 till I think the final one will also be same, like n plus 1 c n. Yeah. So these are the number of ways for 8, the case of 8 specifically, and this is the number of arrays that you will be able to form. Okay. Yeah. Of length 1. This is only for length 1. Okay. Now you also need to do for length 2 also. So let's say for length 2, okay. Now how do we handle for length 2? dp of, if you see that, like dp of 8 comma 2 was equals to 2, right? What does this mean? Like you can form two arrays. One is like 2 comma 4 and other is 4 comma 2. So for now I will only consider this array. So we have like two, this is the only possibility if I am only considering this order 2 and 4. Then I can add a 1 at the end, 2, 4 and 1. This will give me 3 more arrays, right? So 2, 1 and 4 and 1, 2 and 4. And let's add one more. So let's say we have 2, 4, 1 and 1, and I think it will give me, I'm not sure, let's try calculating it. I think it will be 6. It is just my hunch, let's see. So 2, 1, 4, 1. Let's swap these two. So 1, 2, 4, 1. Let's swap these two. So it will be 1, 2, 1, 4. Let's swap these two. So it is 1, 1, 2 and 4. And is there anything left? I'm not sure. Let me just think about this. Like basically what we are trying to do is we just want to create spaces between them and add as many ones as we want. We just want to add the ones. We don't really want to change the ordering of 2 and 4. We just want to add the number of ones in that, because the orderings are calculated by dp. Okay, and this will go on, like it will go on forever, like whatever n that we want. So if you see, like this part, it is represented by like you have a length 2 and j is also equals to 2, so it is like, so obviously in the so obviously in this case we can't start from 0, like we can never have a length of 1. Okay, so obviously in this case we can't have a length of 1. We will definitely start from a length of 2, right? Okay, now let's say I want to have a length of 2 using the elements 2 and 4 in this order. So the number of spaces that are created are actually 0. I can't really create any space here, right? So there is only one possibility here, but here we have a couple of spaces created. Like we have 3 spaces that are created, This is like 3C, and out of these three I can choose any one of the space that I want, right? In this case, not like this. I think it is 3C2. Sorry about that. And this we can represent. And this we can represent by 2C2. And yeah, 1, 2, 3, 4, 5. I think I missed one of the permutation here. Let me just think about this. Yeah, I missed the permutation 2, 1, 1 and 4, right? So this will be like at least 6 permutations, and now it can be represented by 4C2. So you can see a pattern, like this is starting from 2 to n, like how whatever is n, I don't really care about that. But if I write it in summation form, it is let's say j equals to 2 to n. This is going from, okay, let me think about this. J equals to 2 to n. This part is not changing, right? What is changing is this part. So we can if the let's say, okay, we forgot one thing, that is we also have to multiply it by 2, because these arrays that are created only for 4 and 2 pair. They are not we have not really considered right now the 2 and 4 pair, right? Sorry, 4 and 2 pair. What I'm saying. Okay, so these arrays were only counted for 2 and 4 pair. We have not really considered. So this will be equals to dp of 8 and 2 times this number. So it is also valid for 4 and 2. It is also valid for 2 and 4. So this whole number should be multiplied by 2. Okay, now let's move on for length 3. For length 3, you have only one array, that is 2, 2 and 2, and it can go till like 2, 2, 2 and 1, and you can try forming all the permutations of this, and then we will have 2, 2, 2, 1 and 1 till the length of array is n, right? And you can try forming a lot of permutations of this. So the number of permutations here will be 1. The number of permutations here will be clearly it will be 4. So 4 can be represented how? That is what I am thinking. 4 can be represented like 4C3. This can be, the number of permutation will be 5C3 and so on. Okay. Okay. And obviously, since all the next dp values, like for length 3, we only need to go till length equals to 16, right? So the final answer that we will have will be the summation of all these answers that we have calculated. So that is like this part. So dp of let me just write this like this. So dp of first of all length 1, 8, length 1, it will start from something like what was written there, 1C0, 2C1, 3C2 till n plus 1 Cn. Okay, so 1C0 plus 2, okay, 1C0 plus 2C1 plus 3C2 plus till we can go till n plus 1 Cn, right? I think there is some mistake here. We must not go till n Cn. let's say 1C 1, and then we can call it 2C1, and this we can call it 3C1, and this we can call it 4C1 instead. Okay, so yeah, uh, 4C1 till n plus 1 C NCN. Okay, uh, so yeah, okay. So instead of writing it this way, I will write it some in a different way. Sorry about that. It was my mistake. Okay, so we have 1C 1 plus 2C1 plus till the length is n, that is NCN. Okay, plus for length 3 dp for length 2, what do we have? This is what we have for length 2, 2C2 plus 3C2 plus 4C2. So we have 2C2 plus 3C2 plus dot 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 till I think it is NC2, right? I'm not sure why I'm making so many mistakes, but I'm sorry about that. NC and 2. Okay, yeah. And now we want to keep going at like dp of 8 and 3. I'm just writing this down to show you the patterns. Okay, now we can just continue this pattern, and you can easily see like this is for length 3 that we will calculate. So it will be like 3C3 plus 4C3 plus dot 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 till NC3, right? Yeah. So this is the pattern that you are going to follow till this J value is 16. Okay, and when you sum this up, you will have answer. But there is one problem. This n can be very large, right? N is going till 10 to the power 8, 9 into 10 to the power 8, I think. Yeah. So it is approximately 9 into 10. So it is going till 9 into 10 to the power 8. So you can't actually do this. I mean, this step is costing you 16n time, right? So you want to reduce this. So we want to reduce this expression, and at least and how can you actually reduce it? Let's write it in a general form. So okay, so now to actually reduce this whole part, what we are going to do is let's use linear algebra. So what we can do is okay, let's go step by step only. I will just try to write down the general form of this equation. So R C R, okay, plus R plus 1 C R plus dot 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 till R plus N C R. So if you have something like this, I mean, I will just tell you the result right now only. The result is R plus N plus 1 C R plus 1. Yeah. Now this is called the hockey stick identity, at least as it was mentioned in the editorial, but the proof was not mentioned. So yeah, now we are going to actually prove this identity. If you don't want to see the proof, you can skip ahead. Basically we are done. Basically we just want to put this formula in all these equations here, and you will be able to compute this in big of one time, basically. Yeah. So your whole everything will be calculated in just 16 operations, and now and now everything should work, right? So if you want to see the proof, I think it is pretty simple only, not much long. Basically you should have seen the you should know this identity, like NCR plus NC NCR minus 1, or you can even take R plus 1, is equals to N plus 1 C R plus 1, right? I'm sure most of you would know about this identity. What you can do is you can transpose this to minus sign. So this will be removed from here, and this will become N C R plus 1, I think. Yeah. So now you have something like this. Okay, now you can put this equation for all these terms, and you will realize that most of the terms will cancel out. So I will just do that. So for this term it will become like r plus 1 c, this will become r plus 1 minus uh, r c r plus 1. For the second term it will become like r plus 2 n plus 1 c r plus 1 minus, it will become exactly equals to this term if you do that. So r plus 1 c r plus 1, and this will go on till in the end. Basically after cancelling out all these terms, in the end you will have n plus 1 c r plus 1 minus the I think I cut the wrong term, sorry about that. Yeah, you will have this term left, so r c r plus 1. And now you can actually just assume that if this part is greater than this part, then this will be 0. So what you are left with only what you are left with is this term, right? So yeah, I think the solution is pretty much complete now. So the solution is pretty much simple. What you can do is you can first run a for loop for x in range let's say 1 to k, right? Now obviously this you have to do after computing your dp array. So first you need to compute all the dpij values. J can be from 1 to 16 and I can go from 1 to 10 to the power 1 to k basically. Yeah, not 1, 2 to k. And obviously if I is equals to 1, your answer will simply be n. And else case you just need to you need to run a for loop for I going from 1 to 16, and just do dp ij, whatever your answer variable is, answer plus equals to dpij times uh, n plus 1 c, this j plus 1, right? Yeah, okay, so this should be j and this will be like x. So just do that, and after that you can just see out your answer. So I hope you were able to understand the question. Now let's just see the code. Now yeah, we do need modular inverse. And okay, so this function is basically to get given a number, it will return you a vector of the factors of that number. First of all, I'm just caching the factor array because I don't want to do that multiple times. It will just give me it is just a little bit of optimization. But if you don't really do it, you can put it somewhere here, like in before this else block also, that will also pass. Okay, so first of all I am creating a dp array of length k plus 1 into 17, and after caching the factors you can use this to calculate the dp values. Obviously if the length is 1, then the answer will be 1 for dp of I, anything and 1 will be 1. Otherwise you can loop in its factors, and yeah, dp of I upon factor into j plus 1, and make sure you are taking the modulus. After that pretty much the same thing, you go from 1 to k, and if the fx is 1, obviously the answer will be n only. Otherwise you can just use an answer variable. The numerator is oh, I forgot to discuss this part. Now like this value is very large, right? So we can't even maintain an array for this. But you will see that j is very small. This j value is very small, it is only going till 16, right? So that will actually help me. I think I will just erase everything, and now when I write, yeah, it is very smooth now. Okay, yeah. So since n is very large, but j is very small, right? Yeah. So we have these two conditions. Now for small values of n, like if you do NCR, it is equal to n factorial upon r factorial into n minus r factorial, right? Now since j value is very small, right, so since r value will be very small, what you can see is that n into n minus 1, or let me just write it in a different way. Okay, so let's say you want to calculate n plus 1 c j plus 1, right? So this will be equals to n plus 1 factorial into j plus 1 factorial into n minus j factorial, right? And if you open it up, it will be equals to n plus 1 into n minus 1 dot 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 till n minus j plus 1 n minus j factorial into j plus 1 factorial into n minus j factorial, right? And these two will be cancelled out, and you will realize that the top terms are almost 16, and the below terms are also at most 16, right? So this is how you can actually calculate it. That's what I missed in my explanation. So now let's discuss this again. I hope it is not getting blocked by my video. I think I will just move it to this side for now. Yeah, okay. So yeah, in this case, like what I'm doing is I'm calculating the this j plus 1 factorial in this for loop, and then I'm calculating the numerator like this, n plus I minus 1, like that, and then I'm simply dividing these two using modular inverse, and this is what I'm doing. So dp of x j n plus 1 c j plus 1. So this is what we have to add, right? And after that you can just simply print your answer, and that's it. So I will share this code in the description or maybe in the pinned comment, and if you were able to understand this problem, kindly like this video, subscribe to the channel, and I will see you guys next time. Thank you.